With this, we know that the calcium acetate and boron will be okay. They are nicely compatible. In fact, there's synergism between calcium and boron too, so I like to spray those together. And they have the similar mobility too, so you kind of have to spray them right at the place where you need them. So if it's your fruit, on your fruit, flowers, it's very localized. So
spray them every day? You spray them once
no. So this nutrient spray right here, you're looking at 7 to 10 days in between before your next feed. There's also some other quality control that I want folks to understand too, and that's making sure that we're looking at the plant sap.
Yeah, you have to kind of jerry rig that.
There's a refractometer that we can get into in a little bit after this too. We'll talk about that.
Is calibrating mean just getting pH neutral or something? Or?
It's just telling it like, hey, 7 is 7. Here's the 7.
Yeah.
This is what 7 is.
Gotcha.
If you don't have that chlorine, you can add some of these humates. Some of it will dissolve. Not everything's going to dissolve, obviously. There's, again, I remember how I was saying earlier, like all of these things you can make yourself. I make my own humic and fulvic acid. You take this material right here, and you extract it with sodium hydroxide and potassium hydroxide, and then you crush it out with by lowering the pH, and then that way the humic acid will settle, the fulvic acid will remain in suspension, and you can just decant that fulvic acid out, and then whatever's left over at the bottom will be your humic acid. So you can actually make that with leonardite. The only issue with that, again, is making sure that you're measuring your EC, electrical conductivity, so that it's not too high.
Now,
because you're adding salts to it.
the mineral name is that you said leonardite.
Yeah, yep.
Is the name for humates,
Yeah, exactly.
and
They're
is-
derived from leonardite.
Okay, is EC, is electrical conductivity just a plain measure of salts, or is it different than that?
Yep. Measuring salts.
Okay.
Yep. And we'll look at this too here today. And it's in that packet too, actually. The packet tells you at what level they can potentially burn your plant. So it's important to stay below that level. To extract something, I wouldn't do this because I needed real humic acid. This is just whatever the little solubility that exists there that will go into the water.
So for real humic acid, you'd go into the forest and just like take some from under the
You can
leaves?
purchase it.
Oh,
You can purchase it. Or if you have a warm bin,
Yeah.
that leachate that you get from there, that's a lot of it is humic acid actually.
Okay. Yeah.
If you, the way to know whether it's humic acid or not is to put it in water, let it sit. If it breaks apart and precipitates out, that's not humic acid. Humic acid will remain colored the entire time. That's true for your soil. So you can actually take your soil, shake it up. If it gets colored and that color breaks apart, then you don't have a lot of humic acid in there. You're gonna take your eggshells, break those apart, toast them. Once they're toasted, you're gonna go ahead and add 1 part eggshells to 9 parts vinegar. You're basically creating calcium acetate. All right, calcium acetate is readily available to the plant, and you can do this very, very cheaply with just vinegar and eggshells. You will see how you're ready when the reaction stops. So immediately you'll have a nice reaction with the calcium carbonate and the acid. It'll start bubbling up. In about a week, it'll start to dissipate. Now, you can go ahead and swirl it once in a while to make sure that it's actually that the vinegar is coming in contact with all parts of it, which is why you actually want to crush it to increase the surface area. And what you do with this is you actually just dilute that and spray it on your plants. Calcium ready available. This is the only thing that I don't purchase is because it's so easy to make, and Oftentimes we actually take our eggs and throw them in the trash or the compost pile, but this is a better way to use it. And once you make this, you don't really need to make a ton of it either, because typical dilution ratios of this are 1 to 1,000. So it goes a long way.
So humic acid, vinegar, and eggshell.
No humic acid.
Oh, no humic acid.
No humic acid.
Just
Just
water that's-
eggshells,
Yeah.
vinegar. So 1 part eggshells, 9 part or 10 parts vinegar. Toast the eggshells.
Yeah.
And then you actually, and if you can, remove the membrane off of them.
Yeah.
That way they don't foul, so it doesn't foul your extraction. Let it extract for about a week, and you have calcium acetate. That's it.
Would you use that for anything else?
Compost it.
Just compost?
Yeah. Pretty much that extraction is done. You can do another extract on this, but you know
You get
it's going to
less.
be a lower concentration, exactly. But you can certainly do that. This is what happens when you actually forget things. My wife loves how I have things all over the place.
I am bad at that too.
So this is actually an extract that I forgot. I didn't forget. I was just like, well, I should do something with that at some point. But I never did. All the vinegar evaporated, and what you're left over there is the actual crystallized form of the calcium acetate. You can still take that, dilute it in water, and do the same thing, because it's still.
It'll resoluble.
Yeah, exactly. I did this also. You can do the same thing with bones to get phosphorus. And I've done that with the bones, and the bones are really cool because you can see the actual crystals forming off of the bones once it all dries out. But again, another one that I would actually not purchase and I would make myself.
And any vinegar is like strong enough to do.
Any vinegar will do it.
Do you use a specific?
I like to use apple cider jar first, and then we're going to expand it to the 5 gallons. So just going to get some water. I don't want to do all the water at once. You got to give yourself some room. And let's go ahead and just do a little baseline check here before we proceed. I assume this is going to have a decent EC, since it's a living pond.
EC is what again?
Electrical conductivity. And I don't expect this to have a crazy pH. It should be about neutral, but we'll see. The devil's gonna come around. 0.15 millisiemens.
Is the EC conductivity?
Yep. And that was 0.15 millisiemens.
What are you looking for as a minimum for electrical conductivity?
I'm just looking at the baseline right here. The most important thing is when we actually have our final formulation, that it doesn't exceed, what's the number? It's in your handout.
Oh, it is, okay.
I should know this number, but I don't.
If it goes over that number,
It has the risk of burning your plants.
burning, okay.
What we're trying to add here is the calcium acetate. We're adding boron, and we're adding a little bit of our humic acid wash here.
You're getting calcium from the eggshells. The boron is just from powdered boron?
Yep.
Like borax, like you just buy in the stores?
Yeah, this one in particular is not borax, it's soluble boron, which is a little stronger.
Oh, yeah. But boron?
Well, you can still use borax
Borax,
for
okay.
sure. We're aiming at 0.05 to 0.1 in 1 entire gallon. I mean, we're talking minute here. In fact, it's so small that for this jar test, I'm not even going to weigh it because
What is that
I
for?
couldn't. This is the boron.
Okay, what is that for again?
Boron does many things for the plant, but one of the things that it does well is actually steers nutrients. So if you have it in adequate levels, it'll help other nutrients too. Helps calcium. In
Interesting stuff.
vegetables, they actually help form stems. It helps form tubes.
It's all like harvested from the bottom of the lake, isn't it? Mostly.
I believe so. Yeah. Yeah.
It's just like full of mineral. This is a mineral, right?
Right.
Yeah.
So, again, for this right here, I'm just gonna add like literally like a little pinch to that. That's pretty much what I'm doing there for the jar test. When we do the larger one, we'll make sure to actually add the correct concentration.
Too much boron would also burn plants.
Boron has a very, very small window of toxicity and benefits.
Oh, really?
And you have to make sure that you're always, no matter what, always err on the lighter side, no matter what.
Yeah.
So this is again 1 to 1,000 for this, and so what I'm gonna do for this calcium acetate is just do like 0.5 ml to 500 mils. All right.
So it's 1 to 1,000 for the boron.
For the calcium acetate,
Okay.
and you saw how much I added. All right,
Pinch
so
of boron,
It's
right?
yeah, it's a pinch of boron and a pinch of this, and then so this is my wash. Again, not adding much to this. Right, and that's it.
Well,
This is the calcium boron. We want to look at that, make sure that there's no chunks, make sure that there's no strings. We're looking for cloudiness, we're looking for any warming here. We're looking for a violent reaction to occur, or sometimes not violent, but enough of a reaction that it does not completely dilute into itself. It is right. So we want to make sure that everything's incorporated, nothing's precipitating out, nothing's falling out of solution, that everything is in solution and remains in solution.